All right. Good morning, everyone. It is about, well, it's not morning. It's morning, some people maybe. But good afternoon. I'm sorry. It's about 12:58, and we're going to go ahead and get you guys started with some poll questions here. I just want to go ahead and jump in and make sure everybody can hear me okay. So if someone can give me a thumbs up, that'd be great. All right. Sound is good. All right, perfect. If you guys haven't in the previous sessions, if you guys could just give like a few seconds here to answer some of the poll questions that we have down at the bottom, we would greatly appreciate it. And if you guys do start to experience anything weird with the sound or video, please put it into the chat, and so we can get that all situated and help. And Jordan's going to get started here in about 1 minute or so. So you guys just hang tight. And like I said, if you guys have any problems with anything going out, please put it in the chat. If you guys have any questions for him, you can also put those down in the question panel or just put those down in the chat and just take a couple of seconds here to answer some of the poll questions for us. Thanks.
Can you guys hear me okay? I'm going to get started.
I can hear you, Jordan, if that matters.
That does matter. That totally counts. I think I'm just going to get started. I see a bunch of people saying hello, so welcome everybody. My name is Jordan Martz. I'm from Databricks. So I think a lot of you guys have heard about Databricks. We're an interesting solution inside that big data space you guys keep hearing about. But within the Azure space, I look at us as core connectors. Like core connectors to all the different services, whether you're connecting in and out of Cosmos, whether you're loading out of a hyperscale, whether you're optimizing loads into SQL Data Warehouse, whether you're extracting from an event hub. When you think about cloud data platform, you should be thinking with Databricks as glue of all this type of infrastructure. So what I'm going to do is give you my rendition of Databricks, which I guess is the somewhat formal one. But I come from the Midwest area, so I think a lot of you guys probably, I've known a lot of the folks that are saying hello on this channel right now, I have to shout out to. So there's a background around accelerating innovation and big data, and our term for who we are is the unified analytics platform. So when you think about queries that you're used to inside SQL Server, whether it was your Hadoop HD Insights that you were using in the past with Spark, you have to really look at Databricks as a different animal from that type of world. When you look at Spark, think of that as the query. That's an optimization that you can use for traversing data. But what's powerful about Databricks and what's important about the product itself, when you think about it, we're organizing the history of how those files are being traversed and organized across a widely diverse platform of systems and infrastructures, because they've got over 150 different types of infrastructures that can be populated and organized together into the organization of those as an in-memory, what we describe as a data frame, a fundamental platform of a Spark. But Databricks itself is an organization of those data frames as a history of how that was executed. When that history is then taken in, it's optimized. So we can optimize the underlying files. And then we call those files Delta files, because that's part of the organization of loading data consistently. When you think about that organization of loading data consistently, Delta is one of the most powerful tools that I've ever seen in this space. MLflow is another technology in this space where you talk about how I can take the outputs of my predictive models, how I can then coordinate those with the Azure ML ecosystem, and how that works. When I talk about what is AI, the AI ecosystem prior to the cloud, this is what the Natural Language Processing Conference published on this. And when you talk about configuring, setting up data collection, understanding how I'm going to define features, that's a machine learning task of defining, like, organize my columns and organizing how they work together, understanding how I'm going to manage those resources as I execute them, how I'm going to cleanse those data sets, whether just naturally imputing and filling in net new data, or just understanding some business rules and context. That's very easy to do with Spark SQL and the other languages like Python, Scala, etc. And I'm going to bring you into those. I have about 3 demos, so I'm not going to slow down for anybody. When you're talking about the overall experience of like serving the infrastructures and setting up all these nodes, that's one of the fundamental parts of what we deploy. when you're configuring and trying to set up your jobs, most people think about it as I organize and collect information. But what's important here is that you can then take that data collection, data verification, and you can organize it in a way that can then be handled by processes that are being that are actually okay, good. The audio is good. If you've got servers, or actually in our world we call them containers, and those containers are organized in a way that elastically scale. We've been doing Kubernetes for over 5 years. So the ability to understand and monitor and then service, which means you can employ new containers at intervals that make sense, create that process that you're going to be able to do to understand how I'm going to be able to scale my AI and machine learning venture. So as we go out, what we're doing is we're solving some of the world's largest problems. When you talk about fraud detection, like when you, let's say you buy your coffee this morning and the credit card you use to buy that, those ecosystems are all Spark jobs that are extremely scalable, not only integrating the clickstream activity that you're used to, but like your phone, your device that you use to pay for it, and the customer data that goes along with it. It's merged and able to then collaborate and process this information. When you talk about some of the big strategies in the Azure ecosystem around video and speech and tagging, when you're able to do this, these are the things that give you that holistic overall experience. It's not just understanding what's broken on the production line or why my genomic sequence has to be next gen sequenced, and then why I then recommend and buy these type of operations. But this AI journey we're all on, a lot of it was hampered previously, like not only the cloud infrastructure problem, but how I dynamically scheduled and configured all that information. It's a huge part to this ecosystem. There's what does it take to prepare this data? Do I take existing deep ETL tools? Do I convert them to tools like Azure Data Factory? Or do I take in, and then how do I manage that streaming ingest, whether I'm using the Azure Database Migration Service or a CDC tool? So all these different techniques to load, but then when you ramp in and you take that stale data and you process it into this overall system, there are multiple engines that are often incorporated into this overall effort. And this is where you lack the collaboration to be able to achieve certain scenarios. So what we've done is we've taken and created a workspace. This is the core infrastructure at the bottom where we've got the cloud service on Azure. And what you have as well is the transactional volumes that can occur using Databricks Delta, the machine learning frameworks like scikit-learn, the stuff that you're using in Python, or CRAN libraries in R, or using XGBoost to then do hyperparameter tuning and optimize that overall experience, and then deploying this for deep learning with TensorFlow. Our ecosystem, as you look at it from the Azure storage, what you're doing is in this reference architecture, lots of different complexity, and the different steps to then take that complexity and load that from many different types of systems to raw, refined, enriched, and featured into taking in jobs and using the actual workbench that we're going to be working with, actually our workspace, and then taking these models and dashboards and putting them together. What happens is when you take these tools, you need to serve them with Azure ML out to different tools like Power BI and to other systems as another application that's being platform serviced. When you take this, you've got lots of different platform components. There's a whole ecosystem of tools that can be used with our overall orchestration and our tools. So when you're managing your Azure Data Factories on top of ADLS, you could even take legacy systems and then incorporate existing, like Informatica and Talon, or create net new, and even doing Azure ML services or existing tools that are in your ecosystem. Very platform enriched and capable of servicing lots of different use cases. The wide ecosystem gives you all these different tools, and the understanding that we can then service those tools within our tools. Say that 3 times fast. But when you think about it, what you've got here is a wide breadth of integration components to consider. As you're doing this, I'm going to get into a demonstration on our product. I'm going to walk you through what is an Azure Databricks notebook. If I go out to my portal.azure right now and I sign into my infrastructure, the first thing that I do right here is as I'm logging into my portal, I can type in Databricks, right? I can then say Databricks and click on it and spin up a new service. All I did was spin up a service called this internal Azure training, and I'm going directly into that notebook right here. When I go into that notebook, what we're going to be able to do is in that first screen, this is the Azure infrastructure when you log into the Databricks portal. As you guys are working from here, you're going to be able to then take in and run, set up like ML flow, which I'll talk about as we're going. You'll be able to create comments on who was writing what, schedule jobs, or calculate and schedule them from the jobs browser. And you can see all the different times that I've run this different operation. As you can see, my peer Ganesh was running this earlier today. Montel was running this earlier today. So I have a series of different folks that are working, and you can integrate this with the Azure DevOps infrastructure and a GitHub infrastructure if needed. As I go, what I'm going to do is I've got the different terminology. This is a workspace with many different notebooks. I go into my user account, and I could have entire operations, and even like, so I have Azure Portal, I've got serving insurance, fuzzy matching like MDM, running deep learning, customer churn, credit cards. All those different use cases can be organized into what we describe as a notebook. From our libraries and clusters, I'll click on this and show you how I configure that in a minute, but also our jobs tab. Being that we're a platform that services and renders out and deploys incredibly powerful components like containerized infrastructures on the back end across the Azure backbone, you can then go out and you can understand here, whether it's just the Databricks documentation on the Azure portal, whether it's the how to code in Spark and learn those APIs, or how to help us with the forums. We've got lots of different Slack channels. We've got lots of different forums, many different ways to interact with our community and our ecosystem to help move this overall ecosystem together. Where the Spark is the second fastest behind TensorFlow, open source project, and the fact that the core infrastructure still remains, I guess we code as Databricks, 75% of the code on Spark, but we're still helping work with the overall ecosystem to support lots of different vendors and platforms and to integrate across lots of different use cases. So the core of what I was talking about were like rows and columns that would then become the foundation of a data frame. As I'm inputting code, I'll be creating a cluster. In this use case, I go to my cluster here, and let's say I was creating a cluster. I want to create hello Azure folks, and I can create multiple clusters. I can run multiple workloads. And what's important here is the checkboxes are as important as anything on this screen. When you're thinking about it, what you can do is you can scale it out from 2 nodes to 80 right here. And if you want to understand what that costs, you go to the Azure portal and check on the pricing, and you can understand when we calculate it's just cores and memory and put that together. And we can then also, if you leave the thing up, because all of us have probably had a bill for a VPC we've left up and running. I know I have. Well, at least my wife told me about it, and that was pretty funny. But then when I ran this, I've got lots of different configurations that I can run and create a cluster. In the use case that we have right now, I'm going to go back to the one that we were using, this notebook. I've got lots of different clusters, and I can create them for different types of use cases. What we'll do is we'll spin up our first operation. We'll start seeing things output. We start running all these as we're going. And it's spinning up and executing a operation to collect new nodes as we're looking at the context to run our first Spark operations. As we're going to be doing that, we then create these data frames using the Spark API. As you can see here, it's a Python. It's expecting Python Spark, and it's able to run each one of these operations. What you need to also know is that a data frame, when it's collected, like you see in these SQL-like language terms, are run using Python to understand whether I group by something, I sum, I order by. But then also the action is the activity of bringing back data or understanding what is, right? You can collect and bring back data. You can save it to files. There's lots of different use cases below. What I'll do right here is I'll run all below as we're going. And as I'm running each one of these operations, I'm printing out data and creating overall data frames as we go. We call this a ripple, but what this does is it read, executes, and it creates a pipeline as it's going. So in here, we've got a driver operation with multiple executors, and we're telling it, I think that finished. Yep, that's finishing now. We're going to see each one of the executors that are operations and each one of the different steps that execute. So we'll be running Spark SQL on top of data frames that understand how I traversed a data set, what I'm going to traverse physically within there, how distributed the data set is, and how it's being rendered. That all that does is coming from this overall couple lines of code right here. When we deploy that overall code, we're looking at the clarity of a diamond based on clarity and other information, and it figures out by understanding what we call the Tungsten API, what are the data types for each one of these. We then can display it in a real nice tabular format, but this is live data. So I'm able to show you this in a nicer way. Somebody picked a better graph like I did when I thought about it. And then what I can also do is I can understand and view what were the operations that occurred to then go through the stages of execution. So as you're looking at the overall Databricks portal, you're looking at the different tasks that are going to occur. In this one, I create a data frame that's just a group by setting up the cut and the color by price. And I want to join on that to then calculate the average and the carat information. As I do that, I do not calculate that until I understand what I'm going to execute. So this data frame 2 right here understands and executes one of these different operations. And this is just like understanding in like a SQL server how the underlying database was executed. Sounds like there's some of the sound is not coming up right now. So I want to make sure we're okay. Okay, sorry about that. We'll give everybody a minute to refresh their page. But as you're joining data, you can then broadcast and join and filter. And what you're looking at is the ability to filter on data sets, understand that it's a CSV file, push and then figure out how we're going to filter on this overall data as we join things together from where they are located within the Azure Data Lake store. What I've done right here is it's only taken 2 seconds to process. And what you're looking at is it takes 269,000 rows very quickly to return that. As we execute that, we've got a web UI here that traverses these files, sets up partitions, understands how it's going to aggregate these data sets, and it then partitions and joins them together. This is where you get that join, sorting, and merging of the data. That's that Tungsten API, which is part of the overall Spark core. There were 2 main projects. There's the Catalyst, and then there's the other engine, Catalyst and Tungsten. And so the Tungsten is this one, this Tungsten engine. As we're looking at, what we're looking at is the caching. And this is where we build into the Databricks caching functionality, which is something that would be important to learn more about. Because what we're doing is we're not storing the data in memory, we're making the execution more efficient to be able to then understand where that data frame's in memory later on once we lazily evaluate, and then we can execute it and have it in memory very, very efficiently. As you count each one of these services, we're able to then run them, recount them, and what took 2.3 took 0.14 just because we've understood how activity's been run. What I'm going to do is I'm going to go back to my slides, and we've got ML Flow right here, and then Databricks Delta. So I'm going to go into ML Flow. We're going to hop into that. So when you're going into your machine learning journey, all right, you're taking in ML Flow, and you're looking at machine learning development. It's all complex. When you're looking at how I do my raw data to my data preparation, deploy it, and train it, this is all about the output at the end of the day, the clarity of how accurate my data is. And when we look at a holistic experiment, like how you define an experiment as the scientific method describes it, you want to be able to understand what code's changed, what within this code has changed, and then what environmentally around the code has changed. Kind of like a standard life cycle. The Delta file has almost like a backup and restore functionality. You can then go back to a point in time historically. And what we're also able to do is to understand the data quality from a statistical understanding of that data. So as we're training and we're prepping those models, we want to be able to record the outputs into a UI. As we do such, we'll be using what we call the ML Flow. This is all for not only understanding how I'm going to tune the quality. You know, when you're doing your cross-validation, you're splitting up your data, sometimes 80-20, 70-30, but you want to be able to hyper-parameter tune that to figure out what the best optimizations are. And you also need to be able to scale it. That scaling comes into that machine learning lifecycle, so you have ML Flow to define that governance. And you also need to be able to exchange that data. And what we're looking at is you look at ML Flow and you're able to calculate a very efficient way for being able to do that. So let me go into the demo. And we've got all these different concepts such as tracking, projects, and models. And I'll just give you a quick overview. Let me hop back in because I just exported my slides. In the tracking, we want to be able to record the quality of the output. We want to repackage the actual models for later runs. And we also want to be able to have diverse deployment, whether it's between the Azure ML service or within Databricks or other services as well, like actual containers, being that this is a fully open source product. So you can take these notebooks either using our REST API or some Python code or working within our localized UI, like a notebook, and then exporting it out to one of our UIs or defining what code I'm going to spec for either like I'm going to run this model, spec it out so that I have an alerting. If it gets past this band, like 80% of quality is no longer there, bye-bye. We're going to send it back out to you and figure out what's going on. So you have lots of different flavors of models that can be executed. Here's the Azure ML or Spark ML, or just setting up some Docker and container to deploy. What I'm going to do is hop into ML Flow right here. Close some of these down. All right, let's go to the top. So in this discussion, what we're going to do is talk about a diabetes runtime. And in this runtime, what I've configured is Databricks 5.0 within this cluster. Got, a couple of, I think I got 5 different cores, or 5 nodes in total, but breaking out by the different components. And what I've done is I've gone to my cluster. And then we're going to go all. And in this, well, Jiri, let me see if Jiri's got it. I clicked on Jiri instead of Soham. There we go. All right, in here, I've got a number of different libraries. I've got the ML SDK, Event Hubs, MATLAB, ML Flow, Scikit, and Spark executions. When I'm looking at each one of these, I'm going to be training each one of these, and I will then call and install the libraries that were inside that cluster. I can run it from the command line to install this, or I can run some of these operations. You're using classical APIs for setting up data frames for data tables and pandas, NumPy for certain I think about like linear mathematics, but like just basically using Scikit to deploy one of these models. And as you're doing this, you're going to be looking for like how I understand metrics around R squared, RMSE, and MAE. And as you're looking at each one of them, we're going to be taking model selection to do some of these elastic net, which is another way of doing hyperparameter tuning. And then we're importing some of those data sets. So these data sets, as we're importing them, are just some of the open source ones. And as you import them, you're able to then load the data sets and run them over time. So as you look at them, we're going to transpose some of these data sets from like age, sex, body mass index, some of those classic ones. But we're going to be setting up a function right now that's going to reference the actual L1 and L2 regulators, which is just another form of understanding how we're going to elastically manage the different coefficients for this plot. So we're going to return an image. What ML Flow does by setting up an experiment, and in this use case, it's going to show you like how you work with the Databricks file system. So like dbfs or copy commands or running and understanding how the files are. We're going to make some directories, export some of these experiments, and we're going to run them and set them up. So as we train this, we can see what the runs are of each one of these different runs, and we're going to be able to see these outputs as they're being run. So from here, we run the diabetes. We're going to get the alpha and the L1, and we're going to create this eval metrics function, and we're going to return these. Those are then going to be exposed to ML Flow as you print those out to populate this section over here. As we're able to do this, you're able to see and run these ML Flow operations and output them to this overall model. When it creates that, it creates this PNG that gets populated right here to show the different regulators on the coefficients to see the accuracy as we're going to be training this model. Another way of looking at this is you can go full screen into the ML Flow UI to see the outputs per experiment. As you can see this right here. When you're looking at each one of those different experiments, you want to be able to train and operate each one and regulate each one as they're going. So when you look at each one of them, you can display that image that was populated. We're training the different models and we're executing them. Hopefully that makes sense and you guys can see that. So as you're seeing, I know I'm seeing a lot of refresh issues with different folks, and I apologize for that. As we're training each one of these different models, you get the different regulators, and you can then display them as we're going. So this is ML Flow. Hopefully that was helpful. What we do right now is we're going to go into the next steps, which covers us into Delta, all right? So Databricks Delta is a technology that you've probably heard a lot about within the Delta Lake space. So I come from the big data Hadoop world, and oftentimes when you're incrementing a file, incrementing it into a folder, like coming off of a streaming source, it increments one at a time. And as you're doing that, you need to fold it into a larger file as it's going. As you're doing that, you need to be able to execute quickly with performance at scale and correctly. As you do this, you want to be able to understand how I can prepare my data efficiently if it's out of sync. So ETL is important for data warehousing. Sometimes you need to be able to make sure that you have pristine data, fast queries, and transactional data, but sometimes it doesn't scale, right? The ETL doesn't scale, the data warehouse loading doesn't scale, the database requirements don't scale, and there's predictions around machine learning that, like, that's an ad hoc activity after the fact. So what you've got is the actual use case that you've got a complete vendor lock-in that's going on. And as you're doing this, you want to be able to have some real-time infrastructure that can handle for this. And it's not future-proofing your overall environment. Whether it's an on-prem or a cloud data warehouse, you need a new world method for being able to incorporate real-time and prediction capabilities at scale. Hadoop is often centralized for massive scale with cheap storage, stores in these nice files like Parquet and Orc, and it has a lot of things, but it doesn't carry that inconsistent data in those file types. And sometimes it can be unreliable for analytics and complex, and the lack of schema support creates a lot of problems. Although the inconsistent data can often affect the performance of just naturally operating the data, the Hadoop infrastructure, because of the performance of merging things together. So that's not always easy. Streaming systems. Often getting new data quickly and responding to that data is expensive. It's not elastically scaling. There's no predictions, and it's long-term storage and low-level APIs that are separate and expensive. This is something to consider because being able to do things in real time required lots of different tools. When you're hearing all this, you're hearing, I have this tool at XYZ business with these 3 different use cases. Got a data warehouse, Hadoop, and streaming systems all separate. What we've done is we brought those together. The ETL pipelines and the cleansing can happen in real time. The data can be both batch operation or streaming data. They have reliability of the merging of those small files together, like you talked about in Hadoop. The schemas that you have with databasing that gives you that consistency and clarity, that's there. So the concept of having a file type that carries some of these transaction logs gives you that incrementation capability to merge your data together in a distributed manner. So the CAP theorem, thinking of like NoSQL, and the relational world where we had the primary key indexer that we'd carry. Both of those are concepts that are incorporated into the Databricks Delta. But what I also want you to see is that it scales to address the benefits of both of those use cases. Those use cases were drivers for a lot of not only the Hadoop ecosystem, but the use case of why we have large e-commerce systems where the data is just too large and drove the big data revolution. Now, if you can take that data and understand how I can query it, I can take my purchasing of my coffee in the morning. I can be like, okay, well, I bought this. I know I've got fraud detection protecting my overall credit card. I bought, well, here's a drink. I'll say this drink, for instance. And what it's going to be able to do is, how did I buy? What was efficient? So I can query off it. We call that the indexing. That actually is what we call a Z-order index. The ability to have fresh data across different analytics, and then the performance optimizations of those small files, being able to merge them together. So that scale of a data lake and the reliability and performance requirements of data warehousing and the ability to increment that in real time makes it a huge opportunity. What we have with Delta is massive scale, reliability, performance, latency. And when you're able to decouple the compute from the storage, which is one of the things that we do by setting up that cluster infrastructure, we saw that. By being able to validate the data and index it and cache it, and the ability to run this in real time. When Delta is a good fit. So what we're looking at is data engineering complexity, workarounds, corrupt data, and the amount of time spent looking at some of these pain points can be difficult. So we need to have productivity and performance performed. So let's say we've got different files running merge statements on a Hadoop. These are not very efficient. And we were able to handle those changes over time. We were able to use this with that use case. We were able to take billions of rows over 22 people, 4 of which were only ended up being the machine learning, converted that down and repositioned those folks into much more expanded role, and got done in what took them 2 years and 6 months. So these are all powerful, powerful use cases that we have within our ecosystem. Well, why don't I just show you what I'm talking about? In this use case, I'm going to give you like a loan processing scenario. We're taking in data from the web and pulling this one down. So I take this in and I process this data. And what we'll do is we'll set it up so that we're running. I already built a cluster called testing, and it's going out to the web to run different operations around and load them into Parquet files from this Kaggle infrastructure. When I'm bringing those in, it's going to run and read the files, set them up for a cross-validation split, and be able to expose them as the final loans by state infrastructure that will show this. So as we do this, we'll run these operations. We're starting the cluster, so we have to wait for that one. We kick off some of these, create a data table, and we can describe this data. What you'll see is as it's running, it'll populate each one of these. So let's give it a minute to activate. When you have questions, I'd welcome those in the chat window while this is processing. There you go. We just ran this one, running a new command, removing old files, creating new files, and running them. So now you're seeing Spark operate, different jobs process. So there we go. We're rendering data. We're streaming data. And this is where you're going to start to see the first stages of streaming data. You're going to see a Spark SQL statement, which overrides the Python using this interpreter, and it's able to start running and streaming data. Can we implement slowly changing dimensions somewhere? Absolutely. So if you want, I can showcase that to you in a minute. Right here, you're seeing real-time data run. You gotta wait for it to run, and what we're gonna do is run it by state. So I opened up that demo. Give me a minute. So now we're able to run this, and we're running these operations. In this one, we're inserting new values for Iowa. So looking at this one, there's only 2250 right here. Once it finishes these jobs, we're going to run a new set. And now we got 2250 down to 2700. What we're then going to do is we're going to overwrite the file that's existing in here. And you're going to create that 2700 value. And we're going to delete all of Iowa from here. So as we delete this data from what we're rendering, so yeah, you can't run insert, update, deletes on Parquet files. You have to run them on Delta files. So it's updating the files, running a bunch of operations to do this. So it ran a delete. Now that's gone. So there's nothing in that Iowa state right there. So as you're running this, you can run updates. Trying to do that on Parquet, it runs on Delta, right? As we run this one, we're running a bunch of updates and changing the current counts of loans, and we can then run merge functionality. So this is where you're getting into some of that slowly changing dimensionality, that question that's in the chat. And as we're running that, totally fine. It's just one of those, like, are we there yet errors? And as you merge these operations, you see nothing in Iowa, but we're merging two data frames together and creating different data frames that then we can load into a state that's merged on address and state and now populated. Schema evolution is another way that we're going to handle for these different scenarios. where the schema changes, the amount, the address. You can append to different operations. What you really need to do is run what we call the merge schema option. That can then take multiple schemas and then output the transactional information by state, and it can expose that overall system. Time travel is another thing to think about because we carry all the metadata around what cluster ran when, so that you can go back to look at insert, update, deletes. I can then go back to as of a point in time. Or if I load 3 times a day, I can have my version, but I can also do it on the timestamp. When you're looking at this overall power, thank you. So when you look at each one of these different jobs and these different operations, super powerful. So I come from like different processing with Teradata and Netezza, all these different like stage 1 technologies. I describe them were like, it was the data warehousing world. I mean, some of you guys remember SQL DW was called PDW way back in the day. These MPP databases. Then we had this Hadoop thing that happened for 10 years. But the ability to elastically hit in each one of these different steps. So you look at these Spark jobs. These mean that each one of these, yeah, someone talked about a more powerful Jupyter. So yeah, all the tenets of Jupyter are there. If you take in these files and you can export them, IPython is the file type of Jupyter notebooks. But what's important here, and you can also import them, right? So I go to this workspace and I click import. Wait, under my name, I can only do it, import. I can import IPython, so I can take Jupyter code and import it. All we gotta do is mount storage. But what's important here is the fact that you're taking one step of 8 nodes to run one process. You do another step with 8 more nodes to run the same process, or to do another step. Like let's say you're deleting from Iowa and then you're deleting from New York, but each one of those are set one of these different operations. Happy to help anybody through projects. Send notes to the Pragmatic Works team or send me an email at jordan.martz@databricks.com. Hit me up on LinkedIn. I'll just send you my email address. However I need to help you guys, I'm there to do so. But what's really cool is that cluster config started running and it processed a lot of data. We've got about 4 minutes left. So as it's running those different operations, I'm going to shoot down to the beginning where I have a bunch of states, and it rolled back to a point in time, version 9 as of 0, and it brought back Iowa. No, didn't it? No. Okay. So here's Iowa right here with a certain number of records. Iowa still has 0. Let me think. So in my use case right here, I've got 2 Azure Event Hubs loading like data that's coming out. Let's say clickstream is like how I click on my website to how I've got data in Salesforce, right? Like something really, really easy in that use case. But what we're able to do is we're able to merge these different operations together, stream them into an event hub in a very efficient way. As I click on this one, I want to be able to click the upsert. So here's a real life event hub. He creates a table called people data. And that people data is going to merge with another stream called stream updates. That's this merge code. All this is a function call that removes duplicate IDs and brings in data, and then it consistently runs to take CDC operations and consistently merge them. So whether it's the Azure Database Migration Service or any other tool that's out there in the market, it should work for this. Anybody got any more questions? Because I did a lot today. Are architectural automatically created? No, they're not automatically created. You have to create PNGs and embed them. They're HTML. All those images are all HTML. So like I'll download my latest humorous comment from the internet and I can plug it in as a web URL. Yeah, in the notebook, absolutely. So we got 2 more minutes left in the session. I just wanted to say thank you to everybody. Oh, ask the questions. Oh, can I please share? Happy to share. You're going to get an email with a link to the slides. Can Delta be a replacement for a data warehouse? This is one of the questions that's really, really priming up a lot of conversation right now. In many ways, we can do all the slowly changing dimensions, types 1, 2, 3, and 6, right? All the history that you'd want to be able to do for financial analytics. So the demos are available. They're absolutely downloadable and configurable, and I'm happy to go share all that information. I'll share links on where to download all this content and the slides. I'll put it all together for you. But Delta as a replacement, because this is really, really important. If you think about a data warehouse today, it's a lot of the different incremental warehousing loading that becomes relevant. So yes, absolutely available to you to be a joining process, but because Databricks is really based on the machine learning and the ETL, the BI use cases sometimes are served better with a data warehouse. So I have lots of customers that are loading into hyperscale, SQL data warehouse, SQL DB, like the data warehouse in Azure. So they use that overall infrastructure for like larger aggregation level detail. So like I have some queries that the data warehouse in SQL DW can query back into ADLS. So, but I need to run machine learning to be able to get it ready, or ETL to get it ready. So either way, there's lots of options here, but all the low grain detail queries can live inside Azure Data Lake and can be stored and processed on Delta files, and they'll scale. Can this read from a Kafka pipe and perform time-based? Absolutely. If you look on our latest, I'm seeing this all over LinkedIn, but that's because I'm connected to this. In the ecosystem, there's a time series talk that Ricardo's doing. So I'll put it in there. So we take like historical Python APIs. Let me give you a minute to. So there's time series out there. Yes. Thank you, everyone. So we're on to the next person.
All right. There's no more questions, Ms. Jordan. I want to say thank you so much for taking your time out of your day to host this webinar. We really appreciate it. And if you guys think of any questions later on, please feel free to email Jordan or myself. If you guys are looking to attend the next session, just go up in your left-hand corner and click on the button to the next session. It'll take you right there. And thank you guys so much. I hope you guys are enjoying your second day. We are about over halfway done with the second day of Azure Data Week, and we hope to see you guys in the next session. Thanks so much. Oh, and the recording will be available right after this session ends, so probably about 10 minutes after the session ends. So if you guys are looking for that, yes, you can just click right back on to this session, and you guys should be able to access the recording. All right, see you guys in the next one. Thanks so much.